О, терапевтський кидає. Okay, when Anders actually mentioned that I was promised to tell everything in Estonian, I was sitting and contemplating basically either to gaslight him that I never told that, or basically come clean and tell that I was a little bit drunk. But okay. Okay, let's start. Hello, everyone. I'm happy to be here. Thank you that you actually choose my a little bit clickbaity theme, but you will see that it's a little bit more about our journey and how you can actually do pretty much the same. And little bit disclaimer: I'm not a trained speaker. I'm more like an engineer, so I need to have a visual aid. And second one, first two slides will be showing basically myself and my company. So bear with me. Let's start with introduction. Who am I? Well, my name is Sergei. I'm 35. I work as a SRE in a team that is basically responsible for Kubernetes, alerting, monitoring, some automation. I already working in evolution for 9 years, 2016, I think, and this is my LinkedIn. Thank you. And that's it. And that's it. If you want to know something else, come after that. Yeah. About evolution, we actually can see everything here. That it's a pretty big company. It was founded in 2016. We have more than 20,000 people. Yeah. And as for engineers, there's something like 1,000 or 2,000. And as for S3, it's something like 110. Let's call it like that. So we skip this part. Yeah. So what kind of monitoring stack we actually had before introduction to Prometheus in Evolution company? Like many other companies, we use Zabbix as our main monitoring system. Infrastructure monitoring, Zabbix plus custom scripts. Application monitoring, also kind of Zabbix and custom scripts, but we'll talk about it later. It's a whole lot of the story. Even network monitoring, we had a separate team that also utilized Zabbix in addition to Cacti. But we will not touch this team, actually. Zabbix allowed us to have quite a tidy and easily maintainable system with pretty simple approach for alert definition, for notifications, for graphs, for sharing everything with other third parties like, I don't know, even network engineers or data series, even colleagues, let's call it like that. And actually, it's totally satisfied our needs that time. Yes. Here in this slide, you actually can see really simplified scheme how everything worked for our team. Of course, network engineers not included because, as I mentioned before, if it was anything related to application infrastructure or network monitoring, it's basically our team took whole responsibility for fixing and preliminary investigating this issue. Of course, after receiving alert in our corporate email, which later we substituted with a Slack webhook. If it was application, that's pretty much the same, except we had to check application logs, then notify developers, and after that we spent really happy long time fixing some issues and trying to shift blame to each other. You know how this goes. It was a mess. So what happened? One and main question actually, how do we come to conclusion that yes, we need to explore some other options? To be fair, answer to this question will be split into parts. First part of course, bear in mind that it's 2016. A lot of stuff actually changed in this part. First part was actually due to Zabbix implementation and blank spots that we actually had in our application monitoring. So we had to explore what kind of options available at that time. If you want to be more precise, Zabbix relied actually to external scripts Zabbix relied actually on external scripts and agent to push all the metrics. Also, there was a problem with custom configuration because you need to actually know how templates work, how it needs to be applied, how you will actually manage this stuff. And there was really multiple places when we can encounter different bottlenecks. Starting with UDP flood, and then with problems with internal database like MySQL, for example, InnoDB limitations, and to be honest, actually, if we're looking right now on this idea to store everything in database, especially time series, it was really bad idea at that time, until you actually do some modification and some performance optimization, which is already available right now. Second part is just organic growth. But also, I would like to point out that we actually have a lot of blank spots in our application monitoring, as probably many other companies before us. Because we have a lot of metrics around application, like infrastructure, please, servers, by infrastructure, I mean servers, network, all these latencies, all these packets, all this database stuff. But we don't have any application-specific metrics or alerts. Because in order to do that, you need to write scripts and understand basically how your application is working and how to get those metrics. And it's really not our responsibility to do that. And it was pretty complicated to implement in our client then, rather than now. Also, it was actually organic growth, which is really surprising because our company, our company is actually growing. In turn, it's actually led to the quite curious situation because I heard before in this talk that somebody was actually battling with developers that do not want to create metrics and do not want to take a look how performant their applications. But we had actually different situations because our developers started huge refactoring and they quickly understand that yes, we have everything around, but what actually happening inside our applications? How we can actually tell that our refactoring is good, that we fixed something that probably was either, let's call it that, bad code, bad practice, or just basically a bad calculation on their part or on our part, because how you can correlate on that part. So, development team wanted to have deeper information regarding the application performance. They wanted to have access to create graphs that will be useful for them to basically check different versions. Is there improvement or is there not improvement? And also they want actually to have alerts specifically tailored to their needs, which was really troublesome to implement in Zabbix because you need to have different user accounts, then you need to have some introduction for this developer's how to do that, and many other things. It's if I will actually entertain this idea that at that time, yes, we can actually implement this stuff easily. So, sorry, I need this emotional support application on my phone. So when we came in conclusion, yes, we possibly need to explore our options. we thought about our next steps. What our next steps be, and how actually we will evaluate potential candidate. So question is basically why Prometheus? Here is a little bit spoiler. Actually, I did just visual aid. I will not. I will not elaborate about that. So we'll go to the next actually. But we formulated some criteria for potential successors that will be, for now, actually supporting system for only application metrics collection, but after that it will be a successor to our whole monitoring stack. So Zabbix will be basically sunset. And we decide like, yes, we had pretty clear vision, actually. First, scalability. It needs to be easily scalable, since we don't want to be too stuck with solutions that will be used specifically only for application metrics collection. That could not scale according to our needs. It will be really painful to remove it later to some other solutions that will be more scalable. So we needed this criteria from the start. We need to meet it. Second, solution need to be reliable enough to be a new foundation for our monitoring approaches. By that, we want to be sure that even if some metrics missed or unavailable, for example, we would be somehow notified and still will be able to act upon it. Third, it's easy of maintenance and configuration. Solution needs to be compact. Not have complex external dependencies, and all configurations should be easily observable and modifiable either by hand or external CI/CD system, which is actually later solution. Later method of delivery, like through CI/CD, is more preferable for us. Criteria number 4, it's ease of customization. Which actually means that solution needs to have a pretty small and readable code base. So in future, if it needs will arise, we would be able to modify or extend system without too much hassle. Even more preferable was possibility to modify or extend system without touching source code at all. Because let's face it, having your own fork of something, library, application, or any other thing, and trying to maintain the fork with the mainline version, it's a pain. And it's really, we quickly understood that it's a really bad solution to fix some problem. So our requirement was that we can either modify it via API, via utilization of API, and writing some custom solution side by side, or with a plugin system, which actually, since it's a Go application, it's also possible to do that. Yeah. And last one, it's for our developers. Basically, application code itself should be able to expose or send its metrics into the designated endpoint. Because we understand logically that it doesn't make any sense for our team to develop any way to pull metrics from different applications, and it makes sense to delegate it for actually development teams that will actually use this plugin, SDK, or any piece of code, let's call it like that, and they will actually include it into application itself, so it will be self-contained for us. So we will need to develop some solutions that will be dragged along with this application. So, yes, that's pretty much it, I think, for the successor. And again, it was 2016. Market was not so plentiful as today. So we actually had only 3 candidates: InfluxDB, Graphite, and Prometheus. And we actually started testing from first candidate to the last one. We decided to sit with our development team and to speak what is more preferable for them, to push metrics or to actually pull these metrics. And they actually decided to explore push metrics because two out of these solutions actually utilize push model. So we started with InfluxDB, but quite quickly actually decided not to proceed any further with tests because there was I/O problems, there was latency, there was actually problems with graphs creation and many other things. And there was actually rumors that they tried to remove clustering because before InfluxDB you was able to actually to create clusters. And yes, actually, these rumors become true in I think that it was 2017 or late 2016, where they basically wiped all the code base and remove all traces of this code. You cannot find it anywhere. And they started shipping the cloud-based solution, which actually utilizes this code. Second. I apologize. So we decided to continue our test with graphite. Of course, we actually used the basic stack. It's a graphite plus Ceres and megacarbon. And we were a little bit disappointed the results that we got. On paper, graphite, due to its modularity, ease of scalability, and actually support, was perfect. Yes. There was actually a huge disappointment when we understood that Ceres and megacarbon is really immature, complex, and unstable for any serious production use. And main concerns that were raised by instability of main concerns that we had actually was instability of backend storage and also maintenance tools, which is really important actually. And we decided to explore alternatives that could substitute these problematic components and try, instead of basic graphite and Ceres and megacarbon, we use CairoDB, which is basically an alternative solution for metric storage, which utilizes Cassandra. And after some tweaking, hard work, and problems with that, which we overcome, it was perfect. I mean, it was stable, it showed promising results, everything was good, until it isn't. Yeah, why? Actually, we started growing. Instead of couple applications, we started to have 10 applications, 15. And after 15, we already started struggling with getting all this data and had a pretty much drag, which we could not actually solve. For example, one of the problems that we actually had, it has another component that allow you to get whole idea like how many metrics, not how many metrics, what metrics do we have. And in our case, when you just basically clicked on it, you will wait 90 seconds to get all this tree of metrics just to start building your graph. And it was first painful point that we tried to optimize. My colleague actually rewrote all this metrics tree operation, and instead of 90 seconds, it was 2 or 5, which is pretty good. In parallel, we decided to also give a try to Grafana because it started to be, let's call it like that, a little bit more mature. It started to be industrial standard in industry. So we decided like, hey, can we try to use it as a substitute for this component which called something like API Explorer or something, or Graphite API, which also discontinued right now. Yeah, and to be fair, we really hesitated with exploring Prometheus as potential solution, since it required change of how metrics actually gather it. Also, our development team really like Metric Explorer and Graph Plotter with Graphite Finder. Actually, so much that we even had to develop separate components that will be able to get metrics from Prometheus server itself and visualize data in it. It was working in parallel with Prometheus and Grafana for quite a long time, and in Grafana and Prometheus matured well enough that covered all use cases our development actually had. And I want to remind you that we started using Prometheus in, I think that it was version 1.8, and it was really restrictive regarding what you actually can calculate and what you can actually compare in form metrics. And this graphite exporter allow you, for example, just live example, to sum like apples and oranges and receive some results. Yes, it doesn't make sense at all, but it allowed to do that pretty much easily. And so what made us actually certain that we need to continue explore our options and not stick with already working, albeit not without a problem solution, which is Graphite, Keras, and Cassandra. Actually, some errors as before. Issue with backend storage and overall performance, which really hindered our plans and required too much expertise to maintain and fine-tune to at least be some sort of reasonable of being usable. Actually made our maintenance costs skyrocket through the roof, because you need to have not only experience with the Graphite and Keras, but also in Cassandra. And we didn't have this separation. So one poor guy that was responsible for this solution had to juggle between Graphite, between Keras, and between this Cassandra with all these problems, which was really not envious, actually, position. So we finally decided to try running Prometheus side by side, and in the end, it won, actually. How we'll determine that it was a winner? Well, it filled with all our criteria, and in addition, we found some additional reasons why it will be better for us than previous solution. For example, reason number one. Prometheus turned to be really portable solution. Consisted only of single binary, which actually take care of time series, of metrics collection, and alerting actually capabilities. Reason number two, pool-based model. Actually, for us, it was blessing in disguise. Why? Because any monitoring solution that allow you to push or to pull everything is susceptible to bad practices. And by having pool-based model, we actually can control what we ingest, and we can establish our rules, and we can gatekeep everything. We started to be not in position like, okay, what can we do? We need to go to some developer and try to negotiate how to fix this problem. We can basically, come on, out. We will not get this metrics. Yeah. Also, actually, reason number three is that there is quite a lot of scalability solutions, strategies for Prometheus. We can start with simple vertical and horizontal scaling. Like vertical is where we basically decided that RAM is cheap and CPU is cheap. Throw a bunch of it and forget about that. And horizontal is where we basically decided like, okay, we need to solve this problem, and we need to implement some sort of metric separation by designation and by different criteria. And after that, we'll have some another Prometheus in front of that, and through the federation, you will receive all this data. And lastly, strategy which I will not recommend to anyone, it's a sharding. Yeah, it's really, really brutal, but it can be done. Yeah. Also, as it turns out, it has. Sorry. Yeah, I know. I'm also bored myself, bored by myself. So sorry. Yeah. Turn out actually Prometheus and Grafana are really good side by side. Why? Well, because first of all, Grafana take a lot of hassle with creating dashboards because there is available dashboards for you for almost any case at all. And second, actually templating and storing all this locally. And last reason that everyone know actually that whenever whenever you try to do, there is a well-managed support and adoption from open source community. Basically, you have already developed exporter for anything. I even heard exporters that exported some really random stuff, for example, your sleep cycle. Yes, there is such exporter. IoT, node exporter, and different other things. So you will not basically be stuck with something that you need to develop yourself. And even if it's that, you will still have pretty much good instrumentation to develop it by yourself. I mean, you can write some exporter in 50 minutes. I can show you if you want, but later. So, what our first serious steps was actually with Prometheus. It's actually a problem that we identified over the course of the time. With everything mentioned before and all positives that I had said about Prometheus, well, it sounds like a dream come true. This system can actually substitute everything, will work, do not take anything, and you will be in heaven without any maintenance. But no, you will be in hell actually, because to be fair, our honeymoon period ended pretty quickly, and system started to be. I mean, period when why it ended pretty quickly, because our system actually started to be used more and more, but not only us, but our developers also, and more developers actually saw potential and benefits that increased observability bring to the table. We actually cornered into a situation which I will call suffering from success. In this slide, this is the whole questions / problems that we had actually to question ourselves during all these 9 years. Not, of course, in alphabetical order, not, of course, in chronological order, just what we actually questioned ourselves to create a more or less working solution. And let's make a closer look. I think that I will. Let's start with the problem number 1. Yeah. That was actually quite an easy question to answer. Our team already before had all those works. We have already used Ansible pretty extensively for configuration management, and it was just a matter of time when development of new role had been completed, and we actually use it till today. Since I cannot share our external code and we are not published it anywhere, I would suggest looking into this collection. This link you can actually use. That will allow you to deploy Prometheus instance and do a trial run. Then it pretty much also have all necessary exporters, components that allow you to perform some preliminary evaluation, whatever you actually want to stick this with system, or you'll say and like, nah, it's too much hassle. I will not use it. If to be pretty precise, really basic set for you will be node exporter to export metrics from servers itself. It will be Prometheus to scrape this metrics endpoint, and alert manager, which will basically take care of routing those alerts to some defined routes that you will have in routing tree. Yeah. So how alerts will be deployed? That question, I think that we still asking ourselves till today, because it's really a complicated question with no easy answer. But since you're actually starting, I will say that we can theorize how it can be done with different solutions other than that, because as I told before, we have internal code that solves this problem somewhat, but I cannot share it. So, for example, if you bought into my proposition to deploy something into virtual server through this role, first, congratulations, you're in hell. Second, if you will be using something in Kubernetes, we'll talk it a little bit later in the problem number 7, but solution will be pretty much the same, actually. All these problems will expand to each other and will not substitute, but actually give some answers to the previous one. So by the end, you will have some resemblance of understanding how a complete system will be actually. I forgot this word. Not displayed, but how it will look actually at the end. So easiest solution will be actually to have dedicated Git repository with all packed alert definition. This will allow you to place control and manual alert check. And it will gain, for example, you will have really basic pattern, like somebody created MR, you looked at this MR, good, it merged into master, and due to usage of this git sync, which is basically, in Kubernetes it's a side container, but it's a really just a Go application that you can point to any place, and it will be listening to events, not listening to events, it will be basically pulling all this imitate git fetch information, git fetch and all information, and if something changed, it will be basically pulled to the configured directory. So, of course, maybe you're interested how it was solved on our side. Well, at first we had pretty much the same, but it actually evolved. Initially, when we only made first steps and we were not sure what will be going on, we utilized the same Ansible not only for configuration management, but also for alert deployment, which was really bad, but it does the trick, actually. So alerts were basically defined in a separate directory in our Ansible, and as soon as we decided that, yeah, it's time and place that we need to deploy them, we just ran the playbook, and it was in designated server, in designated folder, all alerts, good, nice. We can go basically further. But nowadays it's a really complex system that based on custom labels, based on custom definitions, based on actually testing, we'll deploy alerts in different designated servers for us. So that's how it's actually evolved. For example, problem that you also will be. Oh, there is. I have no time. Sorry. Yeah. I'm surprised. Okay, I will be a little bit faster right now. I will not be reading all this stuff. I will be improvising, so it will be fast. We had our developers looked at our pipelines and tell us like, okay, nice, we want the same one. And we created also in our custom pipeline, we actually added application called pinned, which allow you basically to gatekeep all information that you define in alerts, and you can basically get some sort of rules for your developers and some sort of handlebars for them not to shoot into the knees and really avoid all these problems. Why? Because this point actually can evaluate your expression, and if you're, for example, referencing some alert label, it will basically fail pipeline. If we, for example, want to imitate something like that for yourself, for your pleasure, I don't judge. It's you. You can actually use something experimental, but a new one. It's called Prometheus. Dumb name, don't ask why. Or Pint, which is actually more or less tested solution. And basically that is a separate step where you, before UMR actually go into the master, it will be evaluated under those rules, and you will have some peace of mind that, yes, this alert that somebody defined will actually run, or it will not take all data points and basically OM your system. Also, another problem is collaboration with other teams. For example, if you receive alerts, and question is where to receive it, and how to, for example, share with somebody, and how to act on that. And for that, actually, before we used Alerta, which is a really bad solution, and I will not actually suggest anyone to use it. No. You have actually two viable solutions. One, if you have money, use Opgenie or PagerDuty. Yes, it's expensive. Yes, it's a little bit problematic for use. Yes, API is bad and always is bad. Actually, always bad about Opgenie. Don't listen to me. But you can try to use Grafana On-Call, which is actually pretty much direct upgrade for your Grafana, because you obviously will be using Grafana in your pipeline. I will be fast. How will we scale a solution? Well, that's a good question. For us, actually, how we solve this problem? Before, we were like, okay, vertical scaling is good. We have a lot of money, we have a lot of spare servers, and we basically started to get RAM. If something had problems with getting data points or something like that. After that, we had a problem with disks. We had substitutable for SSD. And after that, we have problem with CPU when we had more and more actual targets. So how we solved that? Actually, we looked at our whole metrics collection system and decided, let's split it. For example, we have application metrics, we have environments, we have infrastructure. Maybe we'll take all this pool of metrics and basically split it per server, which sounds bad, but due to the fact that we actually use Grafana, and Grafana allow you to define multiple data sources in one dashboards, it's not really actually bad, and UX is basically pretty much compensate for this problem. But for example, you decided to follow my advice and both on everything. You can read more in this useful link that will provide you all available options. It will not make sense at first. I will say it like that. But yes, later it will click. And we have another problem, which is writing money. For example, we have alerts, we have hosts, and as soon as you have more than, let's say like that, as soon as you started monitoring more than 10 or 100 or even 1,000 hosts, you will actually stumble on the problem. For example, what if I want to make it like that? My alert is triggering for one host and I want to exclude this host. How can I do that? Of course, you can use negative match regex and exclude this host by alias. That's great. What will happen if amount of hosts started to be more than 100? Then you will have definitions that not only unreadable by any means. I mean, you need to be straight up balls deep and natural to understand what actually meaning and when you actually made a problem to support this this solution. So you will inevitably actually went into templating. In our case, for example, we have at that time, and still we have, at least partially, our single source of truth, where basically all our structure of how many hosts, which hosts, and so on, is that we need to actually monitor, is enanceable. So pretty much logical solution was to implement templating and deployment there. And we done that. We have Ansible templates, we wrote custom code that actually can deploy everything as parallel because Ansible is slow, really slow. And until I think that a year ago, it was pretty much good solution for us. Until we started splitting our repository, and right now we have single source of truth in different place. But for example, let's assume that you will go to the same path as me and we will start to create your own pipeline. Then I think that there is two solutions that can be suitable for you. One is a Gomplate. Sounds silly. Yes, sounds even stupid. But it's basically Go templates on STRs, which can actually receive any data structure. And based on this data structure, it will create your alert definitions. And after that, git sync, goodbye. Everything is good. Or Ginger, if you hate yourself, but don't do that. Yeah. Then we started to utilize Kubernetes. Yeah. Pretty much extensively. I mean, all our old applications from Docker deployment actually migrated to the Kubernetes, and we asked ourselves how to monitor this shit. Yeah. And first of all, we looked into Prometheus configuration, and oh my god, it has actually built-in service discovery. And we tried to make it actually working, but I will advise against that, because you actually cannot control what you receive. You will receive everything, and you will need to create really mind-blowing rules to drop everything that you do not want to basically scrape. And the problem with Prometheus is that when yes, you can drop something, but for drop something, you need to receive something. And you will receive huge data set. Like for us, it was something like 8 million data points per one scrape. And to drop all the stuff, it was really time consuming, and scrape itself took something like 2 minutes, even on our beastly hardware. So we found that actually Prometheus operator took off. And we have actually neat CRD that you can utilize to selectively actually monitor some only aspects of applications. For example, you want to monitor this application, but this application will not get some love from me. No, I will not monitor it. And it can be defined as a code, which you can actually deploy either with Argo CD or any other modern and fancy CI/CD solutions that we have. Flux, I don't judge. Or even you can write your own code, which basically will be something like Helm apply. Yeah. But then question is how we can get metrics from those beautiful and really really loving Prometheus operator that we actually deployed. And for that, actually, there is the answer. In our case, we use federation. Federation is basically an endpoint that you can query the same way as you create different dashboards or something like that, and you can limit amount of data that you will receive. And in our cases, we created architecture where we have beefy machines with a lot of memory, a lot of storage, which basically queried those small machines with limited blocks. It was something like 2 hours, but in reality it will be 4 hours, because when I will not delve deeper. We can tell it about later. So it was working for us pretty well. Even when we started to receive pretty much data sets exceeding 7 millions, 8 millions of data points, and our script started to time out. We had a solution. We just need to limit what data we actually request from federation. And instead of one huge script, we created multiple small ones. In our case, we basically decided, like, okay, we have a lot of teams, and we'll basically separate these scripts into per team. And it still works like that, and it's pretty consistent. I will not dig deeper what we actually building as a substitution. But for example, let's again assume that you decided to follow my lead and test everything. Then I will suggest actually to use something like Thanos or Mimir for a long-term solution, and actually to collect all these metrics from application from Prometheus that is deploying in your different clusters. Why? Because you will actually save yourself a hassle of creating all these different scrape jobs, maintaining this configuration, while still be relatively free and maybe financially a little broken, but mentally you'll be safe. Yes, let's close like that. Next, what we will do to safeguard against problematic metrics, because in my actually experience, I saw things beyond human comprehension, let's call it like that. One time I saw that one developer decided to include SQL statements as labels. We had pretty hard talk between each other, where I maybe tell something that shouldn't be told about some of his capabilities, but after that we actually fix this problem. But let's for example assume that your developers are not so collaborative and do not want to talk with you, or they take actually a lot of time to fix these things. How we can safeguard us? Well, Prometheus have actually no, I don't know how to say it correctly. It's a section in its configuration which is called metric relabeling. Do not actually mix it with relabeling, because it's my favorite actual question with what I ask during my interview, when I interview somebody. And there is a clear difference between metric labeling and relabeling. In your cases, you need to use metric relabeling, which will be basically working as your shield, when you can define, for example, that, okay, this metric called something regex, we don't need. And of course it will be scraped, but it will not be persisted, it will be dropped. So in this case, you will actually safeguard yourself out of writing a lot of bad metrics in your val log, which will try to persist after that. And after that, you will see OEM, which is really fun to actually investigate. And you can ask me how we investigated all this OEM, and it was really fun activity. Yeah. And after that, we actually evolved into a stage how to automate addition of new targets. And as I saw, as I told before, actually there is not correct link, but Netbox, you can Google it. We split all our source of truth in different service repositories. And the only place where when we could actually get information what kind of service we have, and also the fact that we actually grew and we had different other companies that we acquired, means that this approach was not sustainable at all. So we need to develop another solution. And currently, we develop a second iteration of solution. First was using REST API of Netbox to get data based on our criteria. Second one actually used GraphQL. First took something like 40 seconds to get 9,000 targets or something like that. And the second one actually took something like 9 seconds, but it's okay. And to utilize the solution, we actually used there is a field in the configuration for Prometheus called FileSD. Basically, everything that you put there in correct format will be automatically discarded by utilizing a Notify API. File system API, let's call it like that. But let's assume that you're much more braver than me. You can actually use HTTPSD, but I will try to talk you against it. Why? Because when Prometheus starting, until first request will be sent to this HTTP API, it will be starting from blank state, and every alert that you have will be basically null and void. So how Prometheus actually is evolved? To that I need to consult with that, because there is a lot of actual stuff we done. For example, we are currently in a stage of implementing Thanos, because surprise, surprise, bad decision in the past will catch you eventually. And for us, our bad decision was that we don't have any long-time persistent storage for that. We only have local storage in our servers, and what if we want actually to have something like 2 years or 10 years of metrics, which will be scaled accordingly? And for that, we have no answer at all. So right now we implementing and halfly implement Thanos in receiver configuration. And if we are talking actually what in our evolution right now, there is 16 servers split based on designation, based on location. Location is loosely talking. Location in our case is basically a logical path, like we have live 1, live 2, and many others. And we collect 85 million samples per scrape. Yes. Out of that, we actually have more than 40 million unique samples, which we actually persist after all this unnecessary bloat is actually removed for that. And if we are talking about alerts, we have more than 700 unique alerts defined by our development team. At least 200 unique alerts are defined by SRE. And we are not talking about auto-generated alerts, because if we are talking about auto-generated alerts, for our infrastructure cluster, we have 29,000 alerts. Yes. If we are talking about application servers, it's averaging 4,000, 5,000, depending on actual scale of our environment. Of course, our biggest one have biggest amount, but scale. Yeah. Where we're actually currently heading? As I told before, we're actually heading fully into Thanos. we're investing pretty heavily. Right now, Thanos partially implemented because comparing with Prometheus, it's really complex. And we actually gone with the complex architecture, which is receive architecture, which basically worked as you push your metrics. Yes, we gone back. But currently we collect more than 32 million metrics right now with even higher resolution. One block for 1 2-hour block, for example, for our pre-production metrics, have something like 500 million, 2 billion, to 900 million data points, which actually can speak about scale. And this is only one environment. Yes. I can speak a lot about Thanos, not sporadically like I do right now. I'm sorry, I'm first time speaking. Yeah. But for example, we are utilizing actually Thanos Helm chart, and in order to dynamically scale it, and we actually can dynamically scale it based on amount of data that we receive, we use Thanos receive controller. So if you want to replicate this setup, come with me, come to me, I will tell you. And question of the day. If I would start from scratch, what would I do? Yeah. To be fair, I'm actually quite pleased how it's everything turned to be. Yes, somebody can tell me right now that you are probably implemented Zabbix but with extra steps, which is technically probably yes. But the problem is that we really struggled with our ability to scale. And since demand was pretty high, we decided to at least implement one aspect of this system, but implement it very well. And this aspect was basically metrics collection, which allowed not only collect application performance metrics, but also business metrics, and create predictive monitoring based on that, and fully substitute actual Zabbix, because we don't have Zabbix at all right now. And believe me, getting rid of Zabbix, it's really a monumental monumental work. Yes. So if I would start from scratch, probably I will not make the same problem with ditching idea regarding long-term storage. I will, for example, suggest all of you, if you want to start, let's call it like that, right from the start. Yes, use Prometheus, but do not forget about good projects like Cortex, Thanos, Mimir, or even try to use whole Grafana stack. That's pretty much it.